In this video, we're going to apply two steps to solve an equation with whole numbers. So our goal for these problems is going to be called isolating the variable. So our goal is to isolate the variable. And isolate means to get it by itself, or what we're going to do is we're going to solve for the variable. So we're going to isolate the variable. And the reason these are called two-step equations is because it only takes two steps. The first step is we're going to apply the additive inverse property. Which, if you recall, means to add the opposite value. And the second step we're going to apply is the multiplicative property, multiplicative inverse, multiplicative. That looks like an R. And the multiplicative inverse is multiplying by the flip. And the last thing we need to remember about all of this is that when we apply these terms, the inverse operations, we have to do the work to both sides. So for the inverse operations, that's what these are called. We have to do the work to both sides. And we'll talk about both sides here in just a second. All right, let's solve a problem. Using two steps to solve an equation with whole number values. Solve for x. So we have 3x plus 8 equals 47. And the first thing we want to do is we want to isolate the value of x. So we want to get x by itself. So let's rewrite our equation so that we can start working with it. So we're going to have 3x plus 8 is equal to 47. And the first thing we want to do is we want to break our equation in half. So let's split it up by the equal sign here. Let me get a better break. So now we have it broken into two sides, and that's important because we discuss having work on both sides over here. And the first thing we want to do is our goal is to isolate x. So we need to always write out the goal. So x is our variable, so we want to isolate that. And the first step we're going to perform is the additive inverse, so we're going to add -8 to both sides. So add -8. And adding -8 is like subtracting. So you apply your sign rules here. And when we get 47 minus 8, we're going to end up with 39. And this is going to cancel out and become 0, which is what we want. And we're going to get 3x. The next thing we want to do is we need to multiply by the flip. And the flip of this, if I have 3, I need to make it 3 over 1. And so I can multiply by 1 over 3. Now when I simplify this, the 3 and this is going to cancel out and give me 1, so I'm just going to be left with an x equals 39 times 1 is 39 over 3. And now I can simplify this and say that 39 divided by 3 is 13. And so x equals 13 is my answer. Let's look at the next problem. 16 equals u over 2 plus 14. Remember, our goal is to isolate the variable. So we're going to isolate u in this case. We need to apply the additive inverse. And then we need to do the multiplicative inverse. Alright, so let's start working. Let's rewrite our equation. And so we'll have 16 equals u over 2 plus 14. And the first thing we're going to do, after we break our equation in half, is we're going to add the opposite of the constant, or add negative 14 to cancel it out to get 0. (16) plus negative 14 is positive 2 equals u over 2. And now my next step is I need to multiply by the flip. And the flip of u over 2 is going to be 2 over 1. And so what we need to identify is that there is one u, so that means that I put a 1 in front of it. And so now this becomes 1u over 2, and so I can multiply by 2 over 1, and that'll cancel, giving me just u. When I multiply by 2 over 1 here, this will multiply to give me 4 equals u, and that will be my answer.